we are going to add all of the supplementary theorems. All right, so we are going to add same side exterior. And same side interior angle theorems. All right, and these theorems say that when lines are parallel, these angles are supplementary. I'm also going to give you the definition of supplementary because we'll use that too. So, definition of supplementary. And this one I'm going to kind of write like as an example, kind of like we did the definition of congruent. So I'm going to say, let's say that we have angle 1 and angle 2 are supplementary. The definition says that then, so I'm going to draw an arrow, the measure of angle 1 plus the measure of angle 2 equals 180. And I'm going to make this a double-sided arrow because it goes both ways. So like if we started with the measure of angle 1 plus the measure of angle 2 equals 180, we could apply the definition of supplementary to get to the first bit where we just say angle 1 and angle 2 are supplementary. So definitions go both ways. Okay, so let's look at how we might use these guys. So go back to your proofs and let's look at number 10. Okay, so I'm going to give you guys a second to mark up your picture and just talk to your group about kind of what kind of connections you can make between angle 1 and 15. Ready, go.
They're supplementary. Wait, are they supposed to actually? Yeah, they're not.
All right, so let's get started together. So first step, I'm just going to draw my T-chart and write down my givens. So we're given that M is parallel to N and A is parallel to B. And what I do next is I just pick one of the angles that's in my proof. So I'm going to pick angle 1, and I'm just going to be looking for something that has a relationship to angle 1. What do you guys notice?
4 is congruent. 6.
Okay, I heard 4, I heard 6, I heard 12. Those are all true. Let's do 6. All right, so step 2. Angle 1 is congruent to angle 6. What's the reason? Yeah, because they're corresponding. All right. Okay, so now I'm looking back at my proof statement, and I'm noticing my proof has the measure of angle 15 in it, but we haven't talked about angle 15 yet at all. So look at your picture, and now you're thinking, okay, does angle 15 have a connection to something I've already written about, like angle 1 or angle 6? Angle 6, what's the connection? Same side interior. So yeah, so step 3, we'll say angle 6 and angle 15 are same side, I should say are supplementary, sorry. 6 and 15 are supplementary. Because they're same side interior. All right, so now whenever a word like supplementary shows up in my proof that has a definition, I go ahead and I apply the definition because it usually will be helpful. So let's go ahead and apply the definition to supplementary to step 3 in our next step. So step 4, let's say the measure of angle 6 plus the measure of angle 15 equals 180. And the reason is that's just the definition of supplementary.
Is there like a sign you could write for supplementary?
No, yeah, not really an abbreviation for
Can you
that.
just write like SUPP?
No, go ahead and write out the whole thing. Yeah, we'll go ahead and write out supplementary. I guess you could write out SUPP if you wanted. Okay, so what is the one thing in this equation that needs to change before we get to our proof step?
1.
Yeah, angle 6 needs to be swapped out for angle 1, right? Which is okay because we've already said that they're congruent to each other. Now, so notice, as they are right now, I can't swap them out yet because up here we have angle 1 and angle 6, and down here we have the measure of angle 6. So we're going to take step 2 and convert it to measures of angles that are equal. So I'm going to say the measure of angle 1 equals the measure of angle 6
What would be the...
So we always switch between congruent and equal by the definition of congruent. And if you're ever wondering, like, what's the reason for this? Remember, look back at your proofs toolkit and use one of those reasons. All right, so now I have measure of angle 6 and measure of angle 6. So I can take out that measure of angle 6 from step 4 and replace it with measure of angle 1. So now I can say measure of angle 1 plus the measure of angle 15 equals 180. What do you guys think the reason is for this one?
It's not transitive, right?
Right, it's not transitive because we haven't replaced the whole side. So substitution, this one's substitution. If that's tricky for you to see when it's transitive or substitution, you can check because if it's substitution, something should stay the same on both sides. So like for us, on step 4, the angle 15 stayed the same on the left and the 180 stayed the same on the right. So since there is something on both sides that stayed the same, it's substitution. Yeah.
Can't you do the substitution before you do the definition?
Good question. So she asked, can we do substitution step like without step number 5? So we actually can't because on step 2, we only had the actual angle shape. And on step 4, we had the angle measure. And so before you do like transitive or substitution, they both have to have the measure of an angle or they both have to be like the actual angle that are congruent. We can't mix and match congruents and equals. They have to be all equal or all congruent. Other questions? Want me to repeat anything? Okay, so now let's look at another one. I'm going to give you guys a chance to try one. Let's skip to number 12. Oh, actually, I think I want to do number 12 with you. So maybe, let's see. Can you guys try 11 on your own, actually? Try number 11 instead. All right, so let's see here. First, I went ahead and I looked at my proof and I said, okay, I'm going to pick one of these angles to start talking about. And it doesn't matter which one you pick. Let's see. So I picked angle 5. And I thought, okay, what's an angle that's congruent to angle 5? And I found angle 1. So my first step was to say angle 5 is congruent to angle 1. I did that by alternate interior angles. And then I said, okay, well, angle 9 is still missing from my proof. So does 9 have a connection to 1? And I thought, yes, 9 does have a connection to 1. So on my next step, I said angle 9 and angle 1 are supplementary. And my reason was because they're same side interior. Now, this was a step that I saw a lot of you guys missing. When you're writing same side interior, you cannot write an equation next to it. The only thing that goes next to same side interior is saying angle 9, angle 1 are supplementary, right? You can't put an equation there. The equation is what comes next. So next, I apply the definition of supplementary to say that the measure of angle 9 plus the measure of angle 1 equals 180. And that's by the definition of supplementary. So I know it's tempting to kind of combine steps 3 and 4, but they do have to be 2 separate steps. You start with the word supplementary, and then you go to the equation by the definition of supplementary. Okay, and then after that, I'm thinking, okay, what is different about this equation than what's in my proof? Yeah.
So, like, we have to deliver a skeleton to Mr. Nicole.
Oh, yes.
But, like, he's at a conference.
Do you need my keys?
Yes.
Just borrow this one and back.
Thank you.
Bye.
Okay. So the thing that's different is that the proof has angle 5 and this one has angle 1. But that's okay because they're already congruent. But I can't swap them in and out yet because step 2 is congruent, step 4 is equal signs. So I'm going to convert step 2 to equal signs and say the measure of angle 5 equals the measure of angle 1 by the definition of congruent. And then after that, my last step is to sub it in and say measure of angle 9 plus the measure of angle 5 equals 180 by substitution. Okay, questions about that? I know these are kind of longer, but the more you practice them, the more you kind of start to see the pattern because they're essentially pretty similar every time that you do them. Okay, I'm just going to do 2 more with you. Okay, you can do it. All right, so I'm going to add another thing to your proofs toolkit. Let's talk about how you can use linear pairs. So, let's see, linear pairs. So if you see 2 things in your proof, in the picture, that look like linear pairs, then you would say, like, those 2 angles are supplementary. So you'd say something like, you know, angle 1 and angle 2 are supplementary. So pretty much the same as, like, same side exterior, same side interior. Yes?
How would we know whether to write linear pairs or definition of supplementary? Because they're basically the same thing.
Good question. So you always start with linear pairs and then definition of supplementaries next. Or like if you're doing like same side interior stuff, you always start with the same side interior exterior and then definition of supplementaries next.
Wait, so the linear pairs is basically the first part of definition of supplementary? Like, because it's like the same thing.
Okay, so we will start with linear pairs and then we'll use the definition to convert it into an equation.
Okay.
So that we can do stuff like substitution. Yeah, good questions. Any other questions? Okay, I think it'll make more sense when we look at it in a problem. So let's do...
Thank you so much. Have a nice day.
You too. I'm gonna pick another one. Let's do number 12 together. And you could do 12 without using linear pairs, because remember, there's usually more than one way to solve a proof. But I'm just gonna, on purpose, do it with linear pairs just so you can see what it looks like, should you need it in the future. Okay, so we have M is parallel to N, and A is parallel to B.
Oh, never mind.
Oh, and we want to prove 4 and 8 are supplementary. Okay, so I'm just going to circle 4 and 8 so I can kind of visualize where they are. So that'll kind of help me start making some connections. And then I'll draw my T-chart, write down my givens, and then we'll go from there. Oops.
Wait, so why do we actually have to put like the reason? Why can't we just like do it?
That's a great question. So that's the purpose of a proof, because a proof is a logical argument that's solid of why you can do every step. So it's like the reason's kind of like backing up, like this is why I can do it. This is why it's allowed.
Right.
Yeah.
And
Okay. So once I have all that down, I'm first thinking, okie dokie, I'm going to pick angle 4 and find something that's congruent to angle 4. The thing that stuck out to me was angle 5, because angle 4 and 5 are corresponding. And so that's what I'm going to do first. Something else might have stuck out to you, and that's cool too. Because 4 and 6 are alternate exterior. Lots of stuff that you could have done. So in step 2, I'm going to do angle 4 is congruent to angle 5 because they're corresponding. And then I'm looking at what I need to prove and thinking, hey, angle 4 has already been mentioned in my proof, but angle 8 hasn't been mentioned at all. So I'm thinking, okay, does angle 8 have a relationship with the other angle I just mentioned, angle 5? What do you guys think? Angle 8 and 5? Do they have a relationship?
yep.
Sure do. It's a linear pair. Okay, so step 3. We will say angle 8 and angle 5 are supplementary. And the reason why they're supplementary is because they are a linear pair. Okay, remember that when you see that word supplementary, next you're going to apply the definition of supplementary to convert it into an equation. Because only in equations can you swap stuff in and out with substitution. Okay, so step 4, I'm going to say the measure of angle 8 plus the measure of angle 5 is 180. By the definition of supplementary. All right, so now I'm thinking, okay, I really need it to be angle 8 and angle 4, not angle 8 and angle 5. So I'm trying to think, how can I switch out angle 5 with angle 4? And I'm noticing that in angle 2, they are congruent. So if I want to switch it out with my step in step 4, then I need to make them equal first. So my next step, I'm going to say the measure of angle 4 equals the measure of angle 5 by the definition of congruent. And now, since it's exactly the same, I can take this measure of angle 5 and replace it with this measure of angle 4 because the measure of angle 4 and 5 were equal. So in step 6, I can say the measure of angle 8 plus the measure of angle 4 is 180 by substitution. Yes.
It says prove angle 480 are supplementary. It doesn't say the measure.
Yes, we have one more step. Yep, one step. So if you ever want to switch from saying something's equal to 180 to something supplementary, you just use the definition of supplementary again. Because remember, that definition can go both ways. It can get you from the word to the equation or from the equation to the word. So our very last step is to say angle 4 and angle 8 are supplementary.
So do we really need to do it twice?
Yep, and the reason is the definition of supplementary. Because remember, that definition of supplementary takes my equation and puts it back into words. Or it can go the other way. It can take the words and put it in an equation.
I could use my shoe. What's that shirt?
Okay, so I'm going to write down a meaning, and then I'll give you an example that will make it all make sense, okay? So in the meaning box, we're going to say, if angle 1 and angle 2 are supplementary, and if angle 3 and angle 2 are supplementary, then this theorem says that angle 1 is congruent to angle 3. All right, and we're going to go back to your toolkit because I'm going to show you that example that will make that make sense, because I know right now it's just words. So flip over till you find this thing. All right, let's pretend this angle on the left is 30 degrees. And this angle in the middle is 150. Would you agree that they're supplementary? Yes. Let's pretend that the angle on the right is 30 degrees. Would you agree that these two angles are supplementary?
Yes.
Yes. So therefore, if the angle on the left and the angle on the right are both supplementary with the angle in the middle, they have to have the same measure. They have to be congruent. So that's what the congruent and supplement theorem says. If these guys are supplementary and these guys are supplementary, then the two pieces that are supplementary to the same piece have to be congruent to each other. Does that make sense? Questions? Yeah? Okay. Okay, so I'm going to show you it's 3 steps. This whole proof is 3 steps, and it's our last one that uses this thing so that you can see what it looks like. All right, so this one, number 16. We've got that C and D are parallel. And we're told that 11 and 13 are supplementary. And we want to prove 6 is congruent to 11. So I'm first just going to make my T-chart. All right, okay, so what I'm doing is I'm looking at my proof and thinking, well, hey, angle 11 is already mentioned in my proof, but angle 6 is not. Therefore, I'm looking at angle 6 and trying to find a connection to either 11 or 13. Do you guys see a connection to 11 or 13?
6 and 13 are... Same.
Yep.
Same side
6.
interior.
6 and angle 13 are supplementary. Because they are same side interior. So, using these two pieces of information, we could convert both of these things to equations and do some like transitive and substitution steps to show that angle 6 is congruent to angle 11. But that would be a lot of work. So we don't have to do that work because of our theorem we just learned that says if angle 11 is supplementary to 13 and angle 6 is supplementary to 13, then that means that 6 is congruent to 11. And that's called the congruent supplements theorem.